Okay, hello, good evening, everyone. Happy Thursday, happy holiday. Welcome back to our November week 1. Okay, so I don't expect a lot of people to come today lah, since it's public holiday. All right, happy Diwali, thank you. Okay, anyway, let's do our revision. Let's continue our revision today. Okay, so I hope you have received your November notes already. We will be using November notes today, huh? Okay, so let's go into our November notes. Today we will be doing chapter 8, Form 1. Okay, we'll go back to Form 1. All right, so chapter 8, if you still remember, it's not homeostasis. I believe there's a mistake here. Okay, it's not homeostasis, it's actually light and sight. Okay, cahaya dan penglihatan. This is the light chapter, if you still remember, your reflection, pantulan, refraction, pembiasan, and then your dispersion, penyebaran, and then of course your scattering. Okay, we'll talk about that, each of them later. Okay, hang on. Okay, yes, hello Jovian. Happy holiday. We are in chapter 8, Form 1, which is the November notes. All right, so you're just in time. All right, so let's begin. Properties of light. So there are four properties of light that you should know. Number 1, light travels in a straight line, bergerak dalam garisan lurus. Okay, blocked by opaque object, dihalang oleh benda tegap. I think it's called tegap. Here it's called tegap. Tegap means 不透光. That means not the opposite of transparent is opaque. So you will form shadow. Okay, bayang. And then light can be dispersed by water droplets in the sky to form a rainbow. Okay, we shall talk about that later. Disperse is when you split light into 7 colors. And then speed of light is 3 times 10 power of 8. You don't really need to know this. I've never seen this come out in exam before. All right, so 3 types of mirror. You have your plane mirror, which is cermin sata, the flat mirror. Concave mirror, this is cermin cekung, okay, which is the go in one. And then you have your convex mirror, cermin jembung, which is the coming out one. Okay, so how do you memorize this? I memorize this as cave. You go into a cave one. Okay, so that's why a cave goes in. You go into a cave. Okay, cekung. Okay, cekung. And then jembung. I just remember bong as in like a big tummy, bong. Okay, so that's why it comes out. All right, so what happens here? Plane mirror, the lights are reflected in parallel. The lights will be reflected nicely. Whereas concave, they will focus light on one point. We call it converge. Okay, in BM, I just call it non-focus. Is it called non-focus? I don't know. And then diverge is mencapa. That means they are bounce away, they go away. So what happens when you focus light on one point? You will see a larger image. Because you focus on something, what? When you focus on a picture, you zoom in. So the picture will be zoomed in, and then if you bounce away, you don't want to focus something, you will see a smaller image. The thing will be zoomed out. So this one is used in your dentist mirror when you want to zoom in, or your makeup mirror. This thing is used in your blind spot mirror. You know, the mirror at the corner of a supermarket, to see whether you're stealing something. That's the convex mirror. All right, so characteristic of image, you need to know what is upright, tegak, that means standing straight. Okay, laterally inverted is songsang sisi. Okay, that means, okay, inverted means terbalik. Okay, songsang terbalik. But laterally means side by side. Means side by side is terbalik. When you look in the mirror, your wordings on your t-shirt is reversed, right? So that's laterally inverted. Okay, object size same as image size, distance, image distance same as object distance. Okay, you know this. Okay, the biggest problem is real and virtual. Many people still have problem understanding this. Okay, real is nyata. Okay, virtual is maya. Okay, so what is the difference? Real means real. Okay, virtual means fake, doesn't look real. Okay, what does it mean? It depends on whether you see something on a screen. When you see something is on a screen, like your projector, okay, if you still remember our physical class, I use projector, right? If there's something on the projector, something is real. You see a real thing on an image on the wall. So that is what we call nyata real. But if you cannot see an image on a screen, okay, let's say, this is what we call virtual, okay, maya. Okay, let's say I take a mirror, okay, let's say I have a mirror here. You are inside the mirror. Can I reflect you onto a screen? Can I rotate the mirror? You are here. I put you on a screen. I put you on a wall. No, it doesn't happen because your image is not on the wall. Your image is inside the mirror. So this thing is fake. There's no image on the mirror. No image on the screen. We call it virtual maya. That's the best. That's the best way I can explain it. Okay, so real means got image on the screen. Virtual means don't have. Okay, like when you go and watch movie, if there's something on the screen, that's real. All right. So next, the use of plane, concave, and convex mirror. You can read this yourself. Okay. Focus on concave and convex. Because plane mirror, I don't think you need to know everywhere. Okay. Your room has a plane mirror. I'm sure your house has a plane mirror. Your bathroom has a plane mirror. Okay. Nothing much about that. Concave is when you want to magnify something. When you want to zoom in something. Okay. It's used by dentists. Convex is to zoom out something. That's why you use the supermarket and dangerous junction. Your blind spot mirror, basically. Okay, so what uses reflection? Kaleidoscope, which is the one huatong, the twisty thing. Okay, you can read yourself. Okay, and periscope is this thing. Okay. Yes, hello. Happy holiday. Welcome. All right, so we are in November notes. Okay, this is your November chapter, Form 1, chapter 8. All right, so kaleidoscope, periscope, read this yourself. Basically, it's just two reflection over here. Okay, nothing really much here. All right, so let's go into our first part of light, which is the reflection of light. Okay, reflection of light. Pantulan cahaya. I would say this is one of the most important part of this chapter. All right, so law of reflection has two, 1 and 2. These two you need to memorize. Of course, okay, of course, number 1, I is equal to R. That means the incident angle is the same as the reflected angle. Okay, sudut 7 sama dengan sudut pantulan. Okay, I and R is the same. Remember, don't measure your angle here. That is wrong. You measure your angle here. That's why we draw a line here called normal. Okay, this normal line doesn't exist. It's an imaginative line. We put it there so that we can, we know that this is 90 degrees. We know this is a perpendicular line. Okay, so that we can draw an angle here. Okay, so I equals to R. If I use 50 here, that means 50 out, 50 in, 50 out, 40 in, 40 out, 30 in, 30 out. No matter what angle I go in, I will bounce off at the same angle. This is the first law of reflection. Okay, it doesn't change. Okay, you cannot break this law. You cannot break physics law. All right, and then the second point, the second law, the incident ray, the reflected ray, and the normal line all lie on the same plane. Terletak pada sata yang sama. What does it mean? That means these three lines, they are on one side. Can you see? Same plane means one side. That means down here don't have. Down here don't have. Do you see a line here? Do you see a line here? Do you see a line here? No, they are all on the same plane. They are all on the same side. Because mirror bounce off, okay, unless you go here, that's a refraction already. No, so they are all on the same side. Okay, so two reflection law, two laws of reflection. So where do we use reflection? You know this already lah. See this yourself. Your cone, your signboard, your reflector. All right, next, refraction of light. That's the bending of light. This is called pembiasan cahaya. Okay, pembiasan cahaya. So it is when they pass from one medium of transparent medium to another medium of different density. The key point here is different density. Ketumpatan yang berbeza. If I go from air to water or glass, there's a density change. Okay, air is less dense, water is denser. if I go from a less dense place, a not so crowded place, air is less crowded. There's less atom. If I go into water, there is more atom. It's more crowded. I need to slow down. Right? When you drive on a very empty place, suddenly wow, there's people, you need to slow down. When they slow down, it will bend in. Can you see? I go from like that to like that. I bend in already. So you can say that, okay, this angle is still called I, is still called R. I is bigger than R. This going in angle, incident angle, is bigger than the R angle, the reflected angle. Okay, so I bigger than R. Okay, yes, hello. Welcome. We are in November notes, Form 1 chapter 8. Okay, we're halfway already, so catch up. So if you go from dense to less dense, this thing will bend out. Just now bend in, now it's bend out. Okay, very easy. This diagram, if you reverse it, it's this diagram. Can you see? You terbalikkan this thing, is actually this thing. So there's only one diagram we need to memorize. Okay, they go from air to water, they bend in. So if they reverse water to air, they go out. Okay, that's all. So if it goes straight, then go straight. There's no bending here. Easy as that. So in daily life, where do you see refraction? Okay, the breaking of the straw, fish look shallower, the twinkling of star. Read this yourself. Don't need to go crazy here. Don't memorize, word by word. You just need to roughly know the concept of refraction. That's all. All right. So I bet this is like a very forgotten chapter, because nobody likes this light chapter, isn't it? There's so many things to learn. There's so many things that doesn't make sense, and especially the color part. Do you remember the RGB part? The cyan, magenta, yellow one. Oh my god. Okay, I bet you hate that. Never mind. Okay, there's a way to study one. Okay, I'll show you that later. All right. So anyway, the next one is called dispersion of light. Penyebaran cahaya. That is when my light goes through a transparent object. Okay, like a prism. Prism is like a glass, or you can use water. Like here, when they pass through this transparent object, they will disperse. Okay, disperse means they split. The meaning of disperse means split. They will split into 7 colors. So that's a rainbow. Okay, there's a spectrum. So this is how you form your rainbow. Nothing much to say here. Okay, dispersion is white becomes 7 color. That's all. All right, scattering. This is slightly more interesting. Okay, this is slightly more difficult. Scattering is penyerakan. Okay, I want you to take note of the BM. Penyerakan. Okay, these two are two different concepts. Like I said, dispersion is the splitting. Scattering is running everywhere. Very different. Okay, disperse is you and your friend, you guys go away from each other. Scatter means you guys run around. Disperse is in straight line, but scattering is run everywhere. So what do you see? Scattering light, you will see blue sky and red sky during sunset. Okay, so why blue sky? Okay, this happens during noon. Okay, like afternoon, during 12 to 2 a.m., 3 a.m., 3 p.m., you will see blue sky. Why? Because blue light is the most scattered. Cahaya biru paling banyak diserapkan. Okay, so blue is the most scattered. Blue runs everywhere. That's why you see blue. Okay, so let me roughly talk about colors. Roy, GB, okay, red, orange, yellow, green, blue, indigo, violet. The more down the color is, the more easy to scatter. Okay, easy to scatter. Violet is the easiest to scatter. Red is the hardest because red is a very fast color. Red is the fastest color. Okay, whether you can scatter them, it depends on the speed. So blue is around here. Okay, that's why you see blue. Okay, you might say, sir, why no purple one? Because purple there's no more. It's scatter finish everywhere already. There's no more purple left. There's only blue scattering here, so you see blue. Somehow it's blue. Why not green lesser? Why not indigo leh? I don't know. You have to ask nature. Somehow nature likes to scatter blue light more during the noon. Okay, so when it is sunset, when it is around dusk, around evening, you don't see this every day, but sometimes you will see it red. Okay, red or orange or yellowish that color. I mean, when you're painting in pendidikan seni, evening you have to use yellow color, right? So why do you see yellow? Because in this case, just now blue is the most scattered, right? Now there's no more blue. Blue has finished scattered. Red and orange light are the less are less scattered. Okay, that means there's only red and orange left. They are not scattered. Like I said, they are very fast colors. They are not scattered. So this is why you're only left with red and orange now. So you see red and orange, loh. There's no more blue for you to see because blue already scattered in the noon. Now when you're very far away from the sun, blue is no more. There's no more blue. Okay, you might say, sir, you lie to me lah. Sometimes evening is still blue ma. Okay, lor, then there's less scattering that day. Okay, whether you have more light scattering that day, there's a lot of condition. It depends whether there's a rainy day. It depends whether you have dust in the air. Now, let me show you this. Okay, let me show you during okay, our haze time. I'm sure you remember Jirabu, right? Okay, haze in KL. Okay, around like 5-6 years back, okay, we get haze every year, right? Indonesia just have to burn forests every year, and we will just get the haze every year. So, around 5 years ago, you see what happened? Okay, I still remember there was a time, it was so serious that school has to stop because the API reading is around 200 something. It is at the level of unhealthy, so school has to stop. So around evening, you see, the sky looks like this. Why? Because there's more dust in the air. Haze is dust. Okay, when Indonesia burn forests, you have dust in the air. Okay, so when there's more dust, there's more scattering. So you see, yellow color is scattered here. That's why you see yellow lah. You see, it has that yellow tint to it. I mean, not fully yellow, but you can kind of see the yellow here. So you don't see it now because there's no haze. Thankfully lah. You know, these few years okay, fingers crossed lah. These few years there's no haze already. I don't know. Maybe next year they will resume. I don't know. Okay, so you will see sometimes if there's haze, you see yellow. Okay, so 4 things for light reflection. Okay, what is it again? Pantulan. Okay, refraction, pembiasan, dispersion, penyebaran, and then scattering, penyerakan. Okay, sorry my brain sometimes brain fart. I have to translate 2 languages here and there. A bit brain fart sometimes. Okay, so next, let's look at our color. Okay, as you know, our basic colors are 3, which is your gaming color. Any gamers here, you will know what is RGB. Okay, this is the only thing we care about nowadays if you're a PC builder. Okay, I don't care whether what graphic card you have, what processor you have. Wow, your PC got RGB or not? Your mouse got RGB. Any mouse and keyboard with RGB, they can call it gaming mouse, gaming keyboard. Okay, so stupid. So RGB, why RGB? Okay, RGB are the basic colors. You might say, sir, pendidikan seni, I don't learn RGB. Pendidikan seni, I learn yellow, blue, and red. That is not light. We are talking about light. Cahaya. The basic colors for light is RGB. The one you learn yellow, blue, and red, basically our Malaysia flag color, those are pigment. Pigment, color. Okay, the one you use for painting, you use to dye your shirt, the one is called pigment. 色素. Okay, 色素, the coloring you put on your food. The one is 3 basic color, but for light, okay, cahaya is RGB. Okay, so when you add RGB together, you get white. Okay, so you see my screen is white now, right? Why is my screen white now? Because all 3 RGB they switch on. When they switch on, they overlap, you see white color. Okay, so what about if I only switch on green and blue? Okay, if there's only green and blue, I get cyan. Cyan is that light blue color. What if I only switch on red and blue? Okay, I will get magenta, which is that pink color. And then what if I only switch on red and green? I will get yellow. If you notice this, cyan, magenta, yellow is your printer color. Remember? Do you have a printer at home? Which is a very annoying. I seriously hate using a printer because whenever one of it is used out, okay, one of it is no more. Even if you want to print black color, your printer will say, sorry, please refill the ink. But I don't want to print color. I don't need to use cyan. I just want to print black and white. No, I don't care. There's no more ink, please change. This is why I throw my printer away a long time ago. Okay, bloody stupid. Okay, why would I want to change color ink when I only need to print black and white? Okay, that's how they cheat money out of you. Okay, anyway, so how do you memorize this? Okay, many students have difficulty memorizing this. Okay, I like to put a story here. Okay, I like to put a story here. Okay, green, red, yellow, green, blue, cyan, red, blue, magenta. Okay, so you can make any story out of it. Okay, my story is if you go to Mary Brown, okay, MRB is Mary Brown. You know Mary Brown, right? It's a fast food chain. Okay, so if you go to Mary Brown, if you eat GCB, you know it's GCB. GCB is a burger from McDonald's. Anyone of you eaten this before? Guys, please if you go to McDonald's please do not just eat McChicken. Okay, I've asked the student before. Okay, you go McDonald's, what you eat? Oh, McChicken lor. Okay, if there's no McChicken and then I eat filet-o-fish Then if there's no filet-o-fish then I don't eat lor. Huh? That means you have never tried double cheeseburger. You never tried Big Mac. You never tried Quarter Pounder. You never tried GCB. You never tried other stuff. No. So don't be that boring person. Order something different. You have never tried spicy chicken McDeluxe. Come on. Okay, so GCB is one of it. Okay. So okay, you might say, sir, I cannot memorize it. Then you make your own story. Okay. So if you go to Mary Brown, you eat GCB to eat GCB. Okay. Obviously, there's no GCB in Mary Brown because GCB is McDonald's. So if you do that, it will make you gayer. GYR, I call it gayer. That means you're more gay. You are originally already very gay. Now it makes you more gay. Okay, so this story makes no sense. Okay, I'm sure it makes no sense to you. But here's the thing: my brain, the more stupid story, the more stupid the story, the more it doesn't make sense. The more I memorize them. So you make your own story. Okay. So I have a student who says, sir, can I do it this way? If I buy GCB with renminbi, renminbi is the China money, then I become gayer. Because I don't like Xi Jinping, he's very gay. Then okay, fine. Your own version. Make your own story. I don't care as long as it helps you memorize. Okay, can So this is what we call primary color, Warner Prima. Okay, that means the basic color RGB, and then of course the secondary color, Warner Secunda, which is the CYM. Okay, cyan, magenta, yellow. All right, so light subtraction is about your color. You see something. Okay, what do I mean? Why is this mouse? What is this color? This is black, right? Why do you see something black? Why do you see my hair black? Because black will absorb all color. They will not reflect any color. When you don't see any reflection, there's no light. No light means black. Black means no light. So why do you see white? Okay, my single is not white lah. Okay, let's just imagine this is white. Why do you see something white? Because white will not absorb any color. They will bounce off 7 color. You will see white because they don't absorb any color. Okay, so why do you see, let's say, a tree, a leaf, a piece of leaf? Why do you see green? Whatever color you see is because that's the color they don't absorb. Don't. Why is a tree leaf green? Because they will absorb all color besides green. They don't like green. So they will bounce off green. So when tree leaf bounce off green to our eyes, we will see green. They will absorb red, orange, yellow, blue, indigo, violet, but they don't absorb green, so it looks green. Why do you see a red t-shirt red? Because they don't absorb red. Okay, why do you see a yellow t-shirt yellow? Because they don't absorb yellow. And as you know, yellow is made from green and red. So they don't absorb yellow, they don't absorb green, they don't absorb red. Now, when you see secondary color, remember, secondary color is made from 2 primary colors. So you split them up first. Okay, easy, huh? So this color part is nothing difficult really. All right, so let's go to our exercise. Okay, our focus today is the exercise. Okay, I think I took a little bit too much time in the notes. Okay, fine, whatever. Let's go to our exercise. This is page 2. So light and optics. So the natural phenomena that occurs in daily life are due to properties of light. Mark for the correct statement about the properties of light. Light cannot be reflected. Tidak boleh dipantulkan. Of course, this is wrong. Light travels in a straight line. Yes. Light cannot be refracted. No. Light travel faster than sound. Yes. That's why you see lightning before you hear thunder. Okay, so B, match the following natural phenomena with the properties of light. What do you see? Shadow, because light travels in a straight line. Okay, when they hit you, you don't allow light to go through. So when there's no light, there's darkness. Okay, when absence of light, okay, darkness is due to absence of light. When there's no light, you will see black. Okay, so there's no such thing called darkness. Okay, darkness is merely absence of light. It's just like, okay, I hate people who say, hey, please, if you are in an aircon room, they will tell you, hey, don't open the door. Later, the coldness will go out. The cold air will go out. I'm sure your mommy will tell you this. When you switch on aircon, you better close your door. Okay, because the cold air will go out. No, that's wrong. It's heat coming in. There's no such thing as coldness. Coldness is just the absence of heat. It's heat coming in. So wrong. Okay, you don't say don't. Let's say you're outside. Your later when it's at night. Do you say hey, close the door? If not, later the outside darkness will come in. No, darkness doesn't come in. It's your light going out. It makes no sense. Okay, so next one, blue. Okay, you see your blue sky. Why do you see blue sky? Because light can be scattered. Light will just go everywhere. That's why you see a blue sky. Okay, next one. Match the following scientific terminology with the correct statement. What is an incident ray? Remember, incident is the one going in, and reflected is the one going out. So the ray that strikes the mirror, okay, terkena pada cermin, and reflected, the bounce off one is the. That's the answer here already. What reflected, reflected, reflected. What lah? What kind of question is this? Okay, so next B. Okay, if I'm going too fast, you slow me down. You slow me down. Okay. So hope you are still with me. I know it's holiday. You are not a little bit in the mood of studying. Okay, I don't blame you. So next one, mark on the application of reflection of light in daily life. Okay, where do you see reflection of light? Life jacket. What in the world is this English? Okay, this is worn. Sorry, I used to teach English, so I cannot tahan this kind of lousy grammar. Life jacket that wet. Oh my god, what kind? Someone needs to go for English class. Okay, so worn by traffic police. Okay, yes. You know what? It's not even a life jacket. A police doesn't wear a life. You know what's a life jacket? When you go for boating, you go outside. You go in the middle of the ocean. That's the life jacket. It's not called life jacket. It's a reflective vest. Goodness me. I don't see a police wearing life jacket unless he fever lah. Okay, unless he gila or something. No, okay, it's called reflective vest. Oh my god, what kind of question is this? Okay, so number 2. Emergency triangle reflector for vehicle breakdown. Okay, yes, this one correct. Color television, no. This is the addition of light. Okay, penambahan cahaya. Your RGB. So next, number 3. One evening, Yusuf was walking nearby a river. He saw a fish swimming. So complete the diagram by drawing the angle of incidence and the angle of reflection. So what will he see? Angle of incidence, angle of reflection. Okay, so let us just draw a normal line. Okay, this is the normal line. So this and this is the angle. All right, so you might say, sir, which one is the eye? It depends on the direction. You see, where is the light going? It goes from the fish to him, right? So the eye is here. Okay, the R is here. You might say, sir, isn't I here and R here? No, because I is the one going towards and R is the one exiting. You see, the light is going from here. If it is going from here to here, then yes, I is here, R is here. I first, R later. So I first, R later. So it depends on the direction. Look at the arrow. Okay, so next B, underline the correct answer. The angle of incidence is what? Then the angle of reflection. Okay, that means this is I, this is R. If the light ray travels from a less dense medium to a denser medium, okay, less dense medium, that means like air. Denser medium, that means like water. Okay, so from air to water, Okay, this thing will go in. This is not a bit not obvious. Okay, let me draw it bigger. There. Okay, so this is air, this is water. This I is bigger than R, right? Because bend in ma. If I go from air to water, not so crowded place to crowded place, I will bend in. So I to R, I bigger than R. So the angle of incidence is bigger. Okay, lebih besar. This is called sudut 7. Okay, I'm going in is called 7. So incidence in what? Incidence in 7. Okay, number 2, refraction of light occurs or does not occur when light travels from medium with similar density. Similar density. If I'm traveling in water, will I suddenly bend? No. So it does not occur. No. Light doesn't just go in water suddenly, hey, I want to go out. No. It will just go straight. Unless there's a density difference. Okay, so number 4, cloud droplets being larger scatter all wavelength of visible light, so the cloud appears white. So all color is scattered. So 7 colors scattering, you see white color. So A, based on the statement above, determine whether the following are true or false. So gas molecule and water vapor can scatter light. Yes, true. Because your cloud is gas and water vapor. Okay, gas is a cloud. Sorry, cloud is a gas. What? Cloud is water vapor. What? That's how we get rain lah. So yes, they can scatter light. So number 2, light scattering is splitting process of white light into its color constituent. Now, what is called color? What is constituent? Constituent means what is inside. What is inside white light? 7 color law: red, orange, yellow, green, blue, indigo, violet. So juzuk warnanya. Okay, juzuk means member. Inside the member, white light got 7 member. Okay, so yes, true. Wait. Oh no, this is scattering. Sorry, scattering is going everywhere. Splitting white into 7 color, this is not scattering, this is dispersion. Okay, this is penyebaran. Okay, so this is false. Ooh, I almost gonna trick there. So this is false. So number 3, blue light is scattered in all directions, causing the sky to look blue during midday. Yes, true. Okay, blue is the most scattered. Always remember, blue is the most scattered. Our atmosphere doesn't like blue, so they want to scatter all the blue away. Don't ask me why. That's the nature of it. It's like asking me why do we have 2 hands? Because you don't have 3. Because you don't have 1. That's just the nature of it. Okay, number 4. Blue light is the least scattered. No, I just said that it is the most scattered. So it is not the least. Who is the least? Red. Orange. Okay, they are the least scattered because they are the fastest color. They can avoid before they are scattered. Okay, next B. So shows 2 glass block. 2 light rays are hitting a glass ball at different angle. So complete the ray until they hit the edge of the diagram. So like I said, if they go straight, they will continue to go straight. There will be no bending. Okay, since this is glass, right? So this is air, glass. So from less dense to dense, they will bend in. So they will bend in like that. Okay, so this I is bigger than R. Okay, I is bigger than R. And then when it hits the edge of the glass, it will bend out again. Okay, in this case, now I is smaller than R. Because I go from crowded place to less crowded, so I bend out. Just now, not so crowded to crowded, I bend in. Now I bend out. It's just reverse lah. The concept is the same. Okay, make sure you know how to draw this. At least you must know how to draw refraction. That is like the most basic thing you need to know about this chapter. Okay, next one. Number 5, fill in the blanks with the correct answer. The light travels, light, I should be light, okay, whatever. Light travels denser, okay, denser means very crowded, so slower. Okay, lebih perlahan. They slow down. When you drive from highway suddenly to city, there's a lot of cars, you need to slow down. So they will slow down. So number 2, the light rays are not refracted when the incident ray is what to the normal and move from less dense to dense. So you see, this one, less dense to dense. Why is there no bending? Because the normal line is like this. They are 2 lines going the same way. We call it parallel. Okay, when the incident ray is parallel to the normal, okay, selari. When they are parallel, then there's no bending. Okay, can easy. Okay, so next B, diagram 1 shows two natural phenomena caused by the scattering of light. So this is your blue sky, this is your red sky. So based on diagram 1, determine whether the following statement are true or false. Okay, so number 1, the sun looked reddish during sunset because red and orange are the scattered leaves. You see, like I said, red and orange are the least scattered because they're very fast. Yes, true. Okay, diserakkan paling sedikit. So number 2, phenomena S, which is blue sky, occurs because blue light is scattered the least. No, blue is the most. So false. Blue is always the most. Okay, not paling kurang diserakkan, should be paling banyak diserakkan. Blue is scattered the most. Okay, I hope I'm not boring you. Okay, if you're falling asleep, I don't blame you. Because this is a very boring chapter. Who cares about light? Okay, that's why I say physics is a very boring part. Biology, you can very relate to it because it's your body, biology. Chemistry is atoms, okay, you can relate to it. This thing is like, wow, very sad. Okay, you don't see, you don't even pay attention to these things like every day. Why should you care? I know, okay. I'm not even going to try to pretend and say, oh no guys, physics is very interesting. No, interesting for me lah. Maybe for you it's not. Okay, next, number 6, shows two types of mirror, X and Y. Okay, take a look at the black part. The black part is the back part of the mirror. That means this is a convex jembung. Okay, going out, jembung, boom. It's like a stomach, boom. Okay, you have a big tummy. So this one going in is called concave. Like I said, cave because it's going in. Okay, cave, you know, cave, guania, cave, santong, you go into santong. Okay, so cave. So this is jepung. So compare the size of image. Like I said, this one is to bounce all the light away, so you look very small. This one is to make it is to zoom out. Okay, so the image is very small. Whereas this one, I focus light on one point. When I focus something, the thing will zoom in, so the image will be big. Okay, so image of mirror X is smaller than mirror Y. Okay, image, sorry, not Kanta, Cermin. Okay, image cermin X lebih kecil daripada cermin Y. I don't think this is 2 marks. I think this is at most only 1 mark. Because they only want the size of the image. Okay, one bigger, one smaller. Okay, so let's move on. If you need me to go back, you let me know, because if you're not saying anything, I just assume that you have done copying. Okay, so next C, the parallel light rays strike onto a mirror below. Complete the light rays produced from the mirror. Explain your answer. So this is the back of the mirror. This is a concave, as you can see. So let me draw a straight line first. This is a reference line. Okay, so when light comes, okay, it will focus light onto one point. You just pick a point you want to focus to. Okay, this one is here. Okay, so this is the point I focus to. So my light goes like this, my light goes like this. Okay, can you see? Light come here, focus on here, light comes here, focus on here. At the end, they will all pass through this point. So you will see a bigger image because the thing zoom in. Okay, very easy. Later, you take a spoon, go kitchen and take a spoon, a stainless steel spoon. If you look at the back of the spoon, okay, you flip the spoon backward, you will see yourself smaller. If you flip to the front of the spoon, the place where you put your soup, this is where you put your soup, right? You look inside there, you look smaller inside. You are like, no, sorry, bigger. You look zoom in. If you buy those mirror from Sephora, Sephora, any makeup mirror you have two sides. One is the plain mirror, you look normal size. And then when you flip around, oh, you see your face bigger because the thing zoom in for you. Okay, that's why makeup mirror is that for that. You so that you don't need to hold your mirror like that to make up here. No, you just put it on the table. The thing is already zoom in for you. Okay, convenience. All right, so explanation. What to explain here? So you can say the concave mirror converges. Converge means to focus. Converges light onto one point. Okay, cermin cekung memfokuskan cahaya pada satu titik. Okay, focus on one point. So D, give an application of X and Y in daily life. Okay, so where do you use X? What is X again? Oh, X is convex. So where do you use convex? Where do you want to zoom out stuff when you want to see a very big angle? You have something called your supermarket mirror. Okay, so, mirror in supermarket lah, you can call it that. Okay, cermin di pasar raya. This doesn't sound very good. Or you wanna just say anti-theft mirror. I accept also. Okay, this sounds more professional. Anti-theft means 防盗, stop people from stealing. Okay, cermin cegah pencurian. Okay, no problem. Or you want to say blind spot mirror also can. Sometimes when you exit car park, you see like a round mirror there, and then the thing looks like coming out one. It looks like a bowl there one. Or sometimes even your car has a small mirror at the side there. That's the blind spot mirror also, because as the name says, the thing lets you see your blind spot. You know what's a blind spot? Go and ask your dad or your mom, they would know. If you are driving next time, if there's a car in your blind spot, you cannot see one. Okay, if you change lane, the fellow will horn you on, because it's not your fault, but you cannot see that. That's why if you buy newer cars, like car from these 2 years, if you buy a newer car, like let's say you buy a new Toyota, there's a light, there's a small indicator at the side mirror there. If there's a car in your blind spot, the light will show up. Okay, there will be a light blinking telling you, oh, there's a blind spot. There's a car in your blind spot. Don't change lane. You will run into him. Okay, so what about Y? Where do you see your concave mirror? Okay, that's your dentist mirror. Okay, cermin dokter gigi. What else? Makeup mirror, cermin solek. Okay, so next, number 7. Hafiz was doing a shadow activity in a darker room as shown. So state the property of light. He will see a shadow here. What does it mean? Okay, so light travels in straight line. Okay, cahaya bergerak dalam garisan lurus. Pardon my handwriting. Okay, that's as long as you can read it, then my job is done. Okay, so number 2, predict the size of the shadow if the position is away from the screen. Okay, so what happens when I move this bulb away? You just draw your understand. Okay, if my bulb is here, my ball will look like this. This is the shadow, so quite big lah. Okay, so but if I move my light away here, okay, so you draw it again. Now my ball will look like this. Can you see? I move my light away, my shadow got smaller. Okay, so smaller. Okay, menjadi lebih kecil. You can draw this. You don't need to just keep guessing. So the ball is the same thing. If I move this ball closer to the bulb, the shadow will be bigger also. But if I move the ball away from the bulb, the shadow will be smaller. Go and play lah. Just take your go later. Go to your room. Switch off all light. Switch on your camera flash. Put your hand there. Then you understand what I mean. Common sense. All right. So B, Hafiz observe a rainbow form in the sky. So name the phenomena of light. So one color splitting into 7 color. The splitting of light is called dispersion. Okay, dispersion of light. Penyebaran. So explain how this phenomena occurs. So you can say this is usually formed by raindrop. Okay, so white light passing through raindrop. Okay, splitting into its constituent color. Okay, now what is constituent color? Means what's the color inside. If you say, sir, I don't want to write constituent color, I don't understand. Can you write something else? Can split into 7 colors. You like law. Just keep your words simple. It's okay. So cahaya putih melalui titisan air. Okay, menyebar kepada juzuk-juzuk warnanya. Or you can say kepada 7 warna lah. Can. I know the sentence doesn't sound very fancy, but hey, the meaning is there. So who cares? So C, on the way back home, Hafiz saw road construction workers wearing safety vests. It's called safety vest, it's not safety jacket. So with light reflection. So justify the action taken by the worker. Justify means explain. Why are they wearing this? Okay, so this is at night, Okay, usually it's at night. Okay, so what happens? Light from, you can say, this is going back home, right? Most likely it's in a car. So light from headlamp. Okay, headlamp is the car headlamp. Light from headlamp hits the safety vest. Okay, so light hits the vest and bounce to Hafiz's eye. That's why you can see. So cahaya dari lampu hadapan. Okay, kereta, you want to see kereta also can. Okay, terkena ada baju keselamatan. What happens? Light is reflected into Hafiz's eyes. Okay, cahaya dipantulkan kepada mata Hafiz. Ke lah, not kepada ke. Okay, so now the workers can be seen. Okay, pekerja dapat dilihat. Okay, so now you can see the workers. So you will see something if light is bouncing off them. When you switch on your light in your room, why do you see everything? Because light bounces through everything. Light bounce on everything into your eyes. When there's light bouncing off something, you will see something. You will see that thing. Get what I'm trying to say. All right, so you know what? I'm gonna skip question 8 because this is almost the same thing. You will see a lot of reflection and refraction question here. We have not gone into the addition of colors, okay, which is the RGB one. Okay, so let's go ahead. Let's skip this question. Let's go to question 13. Okay, let's go to question 13. Okay, let's go to question 13. 13A. All right, so diagram 11.1 shows the natural phenomenon observed in the evening. So you see red sky here. So this is scattering. So name the natural phenomena. This is the scattering of light. Okay, penyerakan cahaya. Scattering, light running everywhere. So explain briefly how this phenomena occurs. You can say 3 marks here. When light hits an object, apabila cahaya terkena pada sesuatu objek. Wait, this is the sky, right? Then I don't think we should say object already. Okay, sorry, we changed a little bit. When light hits, when light hits, okay, so what's in the atmosphere? Heat, you can say air or water vapor in the atmosphere. Okay, ATM is atmosphere lah. Okay, I'm just too lazy to spell. So apabila cahaya terkena pada udara or wap air dalam atmosfera. Okay, so what happens? Blue is the most scattered. Okay, warna biru paling banyak diserapkan. Okay, so there's no more blue. Blue is finished scattered already. So who is the leftover one? So red and orange is the least scattered. Okay, the sky looks red. Okay, merah dan jingga paling kurang diserapkan langit kelihatan merah. Okay, so 3 marks here. Yeah, blue is the most scattered. Red and orange is the least scattered. The answer is more or less the same one. Every question when they ask about sky is the same thing. Blue is the most scattered. Okay, we don't like blue. The sky doesn't like blue. That's why it looks blue. That's why they bounce blue everywhere. Okay, so next B. A group of students participated in theater presentation, shows 3 types of color light. So you have your RGB. Since they overlap together, right? What do you see here? You should see white color here. Okay, when you put RGB together, you see white. So the 3 colors are overlapping among each other. Predict the color that will observe if the blue is turned off. Now I turn off blue. There's no more blue. So there's only red and green. So red and green is gayer, right? Red, green, you will get yellow. Okay, warna kuning. So explain why is it yellow? Because green and red makes yellow. Okay, so campuran hijau, merah menghasilkan kuning. All right, so this is how your TV mix color. So number 2, a student wearing blue shirt walks to the center of the stage. Then the green light is shown on the shirt. What is the color of the shirt? Okay, so good question. If you have a blue shirt, okay, if you have a blue shirt, okay, why is the shirt blue? Because blue will absorb any color, but blue doesn't absorb blue. Like I said, why is a tree leaf green? Because tree leaf, they will absorb all color besides green. So if you give it green light, okay, if you give green light to the shirt, will the shirt absorb green? Yes. The shirt will not absorb blue, but every other color they will absorb. So this shirt will absorb this green away. So is there any light bouncing off the shirt? Is there any blue light? There's no blue light. So there's no light bouncing off the shirt. So what color do you see? If there's no light, What do you see? You see black. No light means black. Okay, so the shirt will look black. Okay, hitam. Now, it might not make sense to you, sir. This is blue. How come I don't see blue? Because there's no light. There's no blue bouncing off. I'm only using green. Okay, if this is under white light, then you will see blue because inside white light got blue. Now green light only, there's no blue. There's only green color. So the green color will be absorbed. You will see black color. So give your reason. So green light is absorbed by the shirt. Okay, cahaya hijau diserap oleh kemeja tersebut. Kemeja is the shirt lah. So what happens if if I use cyan, what happens? If I give it cyan, what will happen? Okay, like I said, whenever you see secondary color, split it into two primary color. So remember GCB, cyan is made from green and blue. So if I give green and blue to this shirt, what will happen? Green will be absorbed because this shirt will absorb green. Blue, this shirt will not absorb because the shirt is blue. So blue will bounce off. This time you will see blue because got blue. Got blue. If you use magenta, it's the same thing. Okay, if you use magenta, okay, Mary Brown. So magenta is red and blue. So this red will be absorbed by the shirt, but blue will not absorb because, like I said, if something is that color, means they don't absorb that color. So they don't absorb blue. Blue will bounce off. In this case, you will also see blue color on the shirt. Okay, so if they give you secondary, please split it to primary. It makes your life easier. So number 3 shows a cyan light. Okay, this is a cyan light. It's produced when a cyan filter is attached to the front of a white stage light. So this is a white light. Okay, cyan means so GCB. So cyan is made from green and blue. Okay, green and blue. That means green can go through this, blue can go through this. This filter allows two colors to go through. So by using your own creativity, modify the stage lamp so the green light is produced on the stage without removing the cyan filter. So the question says, I don't want you to remove this. I want only green color. Okay, because now green and blue is coming out. Okay, green and blue is coming out. I don't want blue. I only want green. So what do? You put another green filter. Okay, you put another green filter because this blue will not pass through this filter because this filter only allows green. So green will pass through a second. See, I didn't know that our culture has been borrowing culture from each other. Now Deepavali, they also play firecracker. What the hell? Okay, anyway, so green will pass through green. So this is how you make green light. Okay, this is how you make green light. Okay, so this is the subtraction of color. Penolakan cahaya. All right, so you draw this yourself here. Okay, I'm not going to. Okay, you explain this yourself here. Okay, because this second filter will only allow green light to go through. Hanya membenarkan cahaya hijau melaluinya. Okay, or you can say it will block blue light, akan menghalang cahaya biru. Okay, this color part is very important. This is where most people they will ignore. Okay, so that's it for today. Okay, I think I'm gonna stop here. So next week we will jump to the next chapter already, which is Form 2 Chapter 8, I believe. Okay, November week 2 we'll go for another revision. All right, so that's it for today. Thanks for coming. Happy holiday, everyone. I will see you next week. So good night. Take care. Bye-bye.